You're about to watch a realistic mock interview of a complete software engineering virtual on-site loop at Meta. We've heard from dozens of MetaSuite candidates and interviewers about what really happens in the room. Our candidate today, Uma, is a senior engineer at Netflix, and you're going to watch him tackle real interview questions recently asked at Meta. We'll leave links in the description for all the interview prep materials you need, practice questions, mock interviews, as well as links to verified reports about what's actually happening in these rounds in real time. This mock interview is an example of what a strong performance looks like in this loop. We hope you find it helpful, and best of luck in your upcoming rounds.
Perfect. My name is Ani. I'm an engineer at Meta for the last few years. Been working on the backend aspect of things. Been in the industry for about half a decade, a bit over half a decade now. It's great to have you here. Nice to meet you. Today we'll be doing system design interview. And would love to know a bit more about you.
Yeah, absolutely. My name is Uma. I am currently a software engineer at Netflix. Prior to that, I was a software engineer at Microsoft for around 5 years. Happy to be here.
Great. I also have some experience at Microsoft. Um, Sweet. Do you have the link for the for the system design?
Yes.
Um,
I see it. I mean, pull it up.
Perfect. It will be a 45 to 50 minute sort of an interview. We'll go. I'll give you a problem, and then we'll sort of go as we discussed. Feel free to ask any questions, anything, any clarifying questions, any point at any point you feel like you want to just bounce off an idea and see if that's the direction you want to go in. Feel free to do that. Uh, so I want to make sure that this is as collaborative, discussion we can have while we walk through this interview. Sounds good. Great. So today we want to work on a problem that says design chess.com. So, a platform that allows people to play chess. Um, that's all I'll say for now. And over to you.
Designchess.com. I think it would help if I play chess. Okay. An online gaming system. Okay. Let's walk through the functional requirements.
Sure. And again, it's a good point that you brought up that, it would have helped if you played chess. But again, the way the problem is designed, the discussions around it could be, design X, any game for that matter. But yeah, like that's if we were choosing chess for that matter. It is not required that you have played chess.
Awesome. Okay. What features do we want this system to have?
That's a good question. Let's discuss together. When we are playing, let's say it's a two-player game, where at a point two people play together. Um, that's the crux of it. There are I don't know if you've at all played chess, but basically, player one will make a move, and then the move needs to be valid. There are pieces on the board, and player two makes a move, and similarly, it needs to be a valid move where there are pieces on the board and you can whether that piece take that move or not, that sort of thing. So that is what we need to ensure. A few other things that we can look into is sort of ensuring that each player matches with their level of player when they want to play a game. Um, any online board game or any game that you can play, there will be different levels to each player, right? So player of level 1 should be our it is our best effort to match the player of that category. It is not always guaranteed.
Okay. So schedule. That's it. Okay. And then finally, best effort to match players in the same category. So multiplayer online game. So multiplayer meaning these players could be anywhere in the world.
Yes. But each game will have 2 players.
Okay. Right. Okay. Each game and players. All right. Players make moves, and then those moves are valid. So in the case of chess, certain pieces can only move to like certain places, and then we have to make sure that that's valid across the game. Okay. Before you play, ideally you want to schedule matches. So do we want what does the flow for that look like? Do we want the players to be able to do that in advance? Is it that you go online and you can find a random person who's also looking to play and then it then matches you, or what does that look like?
Yeah, no, that's a great question. Let's assume the signups and all that, the leveling has already been decided in a manner that, you have been playing that. The part that we want to focus on today is player one goes into some sort of an arena and be like, I want to play a game. And when they click a button or something along those lines, we find online players that are also trying to play a game. And then we match them with that level or, and level +1, -1, and so on and so forth.
Okay. So 3 and 4 kind of like the same essentially. Okay. So there's sort of a lobby of players waiting. And then our system is doing a good job. Okay. Maybe not chess, but then if you've played any online video games, then it's kind of similar as well with like Warzone or any other game. Okay. Are these are the main functional requirements, right?
Yeah, in moves are valid, things come into we don't when the game is over, right? Like when there's a check and checkmate, we should ensure that no more moves are made. We can't go back or anything of that sort. So, sort of a rules engine is something that we can think of. Anything else that comes to your mind, happy to add it to, the later things. But these are the parts that I want to work on today.
Okay. Sounds good. Sounds good. Let's talk about how the system should behave. Any non-functional requirements, so things related to scale, how many users do we want to support, how fast do we want the gameplay to go. Yeah.
So in this case, I think we should have about 500K concurrent games. So scale should is pretty big. Um,
Yeah, a lot of users like chess. Okay.
Whenever you play any online game, what do you think generally the latency requirements should be, in your opinion?
So if it was like a POV game, like we're talking like Call of Duty, Warzone, Halo, then you want that to be very low, obviously, almost near real time. But with something like chess, you still don't want you don't want there to be a lag. So maybe less than 150 milliseconds.
Around 100, 200, I think that's a good area. I mean, very real time in that manner. Uh, and one thing I'd say is the ordering of the moves should be valid. So we should ensure that if a player one is going first, we should not process player two move first or anything.
That makes sense. In terms of, you said this was 100 to 150 milliseconds.
Yeah, 100, 200 is good.
Okay.
What else comes to your mind when we're talking about games and non-functional requirements?
Um. So we already spoke about ordering of moves should be valid in terms of security and cheating, right? We don't want people to cheat. So, yeah, that comes to mind. Leaderboards, but that would be more.
That's fine. Leaderboard is not something we want to look into. Cheating. Let's assume for the context, we'll assume people are not using AI. Um, rules engine is what the cheating will take care of. One important thing I would say is fault tolerant because uh, servers can go down and all that sort of thing can happen. We should ensure that every game is processed in a manner that
As
is
in, we can recover if
yeah,
something goes wrong. Yeah.
and as soon as possible, basically. Like stability recovery is very important.
So thinking through this, I want to quickly just go over the personas, um, or the NTPs. So we have players, These would be the people playing the games. We'll also have sessions. So I'm thinking of sessions as
As a game session.
yeah, essentially, right? So two people are in the same session, they're playing. There'll be moves that can be made within sessions. We'll have to validate those, and then there's make moves, rules engine. I'll add rules for now, but that will be closely tied to a move to see if a move is valid or not as it relates to a specific rule, and then so players will have ratings as well, so that we can match them to certain categories, so that we do our best effort to match. So these are the entities that I'll start with, and then I'll make modifications, add or remove as I design. So I'll move on to the high level design, if that makes sense.
Let's get into APIs just a bit. I have an idea of what that would look like, and then we can go into design.
Okay, APIs. So the way the players would connect to the sessions won't be. There are multiple ways you could do it, right? We could send a request, like REST, like HTTP REST, right? You have two players, they send to our session, and then we then validate and then do that. The problem with that might be that maybe slower. There may be we may be able to guarantee the ordering, but that will have to happen on the server side as well. That would happen on the server side because of the state. So to keep things live, also we will have to. Oh, okay, yeah. If we do that, then in order to make sure people don't cheat as well, we have to send the whole game state along with each request in some form. So I think a better way to go about this would be using web sockets for the players to connect to the session. So I think it's something like this. It'll be a session ID.
Yeah, we don't have to specifically figure out the format.
Okay,
That's
Alright.
fine. Yeah.
I was gonna say the connections between the player and the sessions would be via WebSockets, and pretty much everything that happens where the players makes a move that's connected to a session, and then the validation, all of that will be server side driven. Reason being, the second we have that on the client side, then there's a lot of issues that can happen, especially with games, right?
Yeah, aspect, right? Like people can start playing around with all that. Quick question: Will everything be happening through a WebSocket, or once the session has started is when the WebSocket will come in, so? Okay, what I'm trying to ask is when someone goes into the lobby and be like, I want to play a game, are also driven by WebSockets, or is it more like HTTPS at that point, and then we come into WebSockets?
So right now, on top of my head, only like during games sessions themselves, that will be WebSocket. So I am in a game, and another user is in the same game, right? And we're playing. That's driven by WebSockets. When you're in the lobby, there's multiple ways we could do it, right? So you step into the lobby, you say you want to play, right? The lobby itself could be a session, right? But inside that session, we're trying to find other players, right? There's could be some sort of matching mechanism happening there, where we could do a long poll, right? Where you say you want to, a short poll, where you say you want to play, and then we then go search for players for you, and then when we find someone, we then say, okay, everything is good, and we direct you. We could do a long poll, which is you send a request. Yeah, sorry, that would be a long poll where you send a request, and then the server holds the request until it finds a response for you. Then it then sends you back, or you could just be directly connected to this lobby via WebSocket as well, and then just wait until we then find. So in that case,
Quick one.
yeah. Yeah, exactly. So I've kind of listed them down. Let's go with the web socket for now as well. So you're connected to the lobby via the web socket, and then if there's any changes, right? Yeah, in the future as well, I can also change that. Yeah,
Just to understand, you're saying we'll have a WebSocket, like a lobby sort of WebSocket connections, and then um, once a game starts, we'll create a new WebSocket connection where the game will have its own
exactly.
connect. Sweet.
Exactly. Yeah.
Um, Great. Yeah, I think. I mean, if you want to add more things to an API section, great. Otherwise, I have an idea of what you wanted to do.
Perfect. Okay. Sounds good. I'll start doing the high level design. So we have our entities, which are players. Let's say this is player 1 and then player 2. Let me go through. So multiplayers playing online. We'll have a service in the back here. Let's say this here. So I have both of them. Let's go. Okay. So this would be our. So there'll be two ways we do this. So we don't want to have. We could have the same service in the back end handle the lobby and this game sessions themselves, but I would separate it ideally because imagine there's 100,000 people in the lobby. That would affect the performance of the game as well. So for now, we'll put the two people separate. So we'll say lobby, and then game session engine. So the aim of the lobby, like I said, is for players to go find people to play with. So I'll put this here like this, and then same thing with this. But I will make them dotted real quick. That way, they signify that once you get your match in the lobby, you're connected by a WebSocket. You then a new game session is then created that you and your player are then connected to. Regarding how the players are matched within the lobby, I will come back to that in a sec. I just want to fulfill the main requirement. So, same thing here, and here as well.
I get the idea.
Yep, but this would be sorry, actual gameplays. Okay, so okay, let's move them apart. Okay, so once a game session starts, the game engine itself would be responsible for creating the game to start, right? So it's just you have whatever visual of what the game is, right? It's like the
Pieces are put together.
pieces, spawn, all of that. That would be. I'm thinking through how that would work in terms of the UI. So since everything is server driven, my thought process would be every time a game is created and a move is made, we validate that on the engine and then send the updated state of that game to the users. But we also want to store that as well after every single move. So I'm thinking whether to store it after every single move or after just the latest move, right? Like the latest validated state of the game. So let me just quickly draw a separate listing for that. We use a data store to store we'll call this game sorry last valid state. So game states. And this is one way. Yeah. So whenever the players make a move, we send the game engine checks via our rules engine, which is separate. And I'm thinking through the rules engine real quick. So for chess itself, validating what a valid chess move is tricky. I don't know how to play chess, to be completely transparent. But the idea being, I'm guessing that process, my thought process would be that process would be involved. If it would be involved, then I would want a separate service to handle all of that. Otherwise, if it's something like checkers where you're just checking this thing, then it'll depend on how heavy that compute is.
Let's assume we would want a separate service. Like there are a bunch of rules to look into.
Okay. Yeah. Okay. The rules engine. So, there's multiple ways I'm thinking about this. So we would send with each move, we send our state of the game to the rules engine. It checks. If it's good, it sends it back. It sends a new state. The rules engine could also, just to make sure people don't cheat. Hopefully people are doing things well. To make sure that the system works well, we could also use the previous game states, to make sure that we haven't somehow ended up in a certain state that is not possible. Does that make sense?
If our rules engine is working valid, can we even have that state?
That is a fair point. Technically, we shouldn't be able to. But my thought process is the game states here is primarily here to make sure we can rebuild if something goes wrong. We basically rebuild that. So yeah, if our rules engine is working properly, then there should ideally be no way for us to
So the
look in that state.
responsibility of validating on the rules engine and the game session engine, so that this particular part of the component is not isolated, but like a very strict, or not strict responsibility of what it is game state is trying to do.
Okay. Yes. So the game session engine handles all the active game sessions. With each move, we send every single thing via WebSockets to the game engine. It validates, it sends it back. While after a valid move has been made, we also store the state. That way, if something goes wrong, we can easily rebuild from the game as well. So going back to players being able to schedule matches and then them being in the lobby. So best effort to match players in the same category. Let's think about how to do this. So ideally speaking, the players have signed up, they've registered. We have an idea of how many games they've played, whatever I believe it's called ELO score or ELO ratings, whatever it's called. Yeah.
Let's say they have like some sort of ranking or level.
Yeah, exactly. So it would be a process that goes and figures out who is available to play and tries to match them together as best as we can, obviously. There should be some, ideally, there should be some wiggle room in there, because we may not be able to find one-for-one matching, right? If someone is a brand new beginner, depending on who they want to play against as well, there could be some wiggle room in there, yeah.
At this point, what I've gotten from your conversation is let's say 100K players, or actually if there are 500K games at the peak of our hour, that means there is 1 million users, right? Everyone can match with each, then we have twice users. How do we, I want to go into this and understand, are we iterating through each, like brute force way, right? Is to pick up each player, see which one is the ideal match, sort them, and then pick the one that is matched by that particular person's rank, right? That's the brute force way. It will work for one-on-one. Like if there were 3 players altogether, it will work. But how do we scale it to, when we have 1 million users, or we eventually want 500K games there?
That is a good question. Let me think through. So we don't want to do one-on-one for so we essentially want to make the pool of players that we're picking from smaller. That way it's easier to search within a given pool, right? So we'll group the players based on their skill level, and in our backend database, for the players in the lobby, we'll basically group them, and then we can then search within the groupings.
So
That's the first. Sorry, go ahead.
yeah, no. At this point, you're saying in our database we'll store all the players that are ranked.
Yeah, and their rank, right? And so we'll then have that in the database right now within our lobby as we're trying to match players, right? When we're querying, we're not now querying. Also, these are players who are also live, who are also trying to play, right?
How
Yeah.
how will we manage that?
How will we know that they're live and they're trying to play? They're actively connected to the lobby via the socket, right? So right now it's just player 1 and player 2, meaning like they were in here and then they were matched and then they then went in here, right? But I ideally speaking, it could be that every like I said earlier, like every player who wants to play is connected to the lobby via WebSocket.
But how do we have, like, where do we have that information where we are saying this is it? There needs to be some sort of state management that is happening where we're like, these are the players that are online right now, whether that we are identifying it through their WebSocket connections or whatever you're trying to use. But how do you know the players that are online at this point?
So the players that are connected to our lobby via WebSockets, we can store that information. We'll have their rankings in the database, right? But we don't want to pull from the database each time. So we could use faster memory since we want, since it's a lobby and they're trying to rank. So ideally we'll put some sort of caching, in memory data structure. So maybe a cache here. That way, the players that are in our lobby, the information on all that information about them is pulled from the cache, and then we then use that to match based on what level they are and what we know about them.
Okay, I like that. How, again, just trying to understand a bit further, right? How are you storing in the cache? Like, is it a key value? Is it like, what's the idea? Again, you don't have, if you think that's not something well thought out, right, we can move forward.
Yeah, so my thought process there would be similar to how we have them in our database, where we have all that information on them. We group them in our cache system, rather in our cache in-memory data structure, and then so instead of just like all the players, we have like level 4 players, level 5 players, level 6 players, and like different tiers and in like different buckets.
So what you are saying is basically we'll have something like this. It's a key value store at the end of the day, but we have like L3 and then a bunch of IDs here, ID1, ID2, so on and so forth, and L4. So when someone comes to us and be like, I'm a L1 player, we add it here. Or pick any two of those players at this point and match them up.
Yeah. Yes. That's the thought process. Yeah.
Okay. That is good. Lobby. Is it one big session? How is lobby sort of scaling well? If we have
Lobby will. Oh, okay. That actually adds some challenges. So we could have multiple lobbies, but if we have multiple lobby sessions that different players are joined to, then it may make it trickier to then kind of like match them based on which lobbies they are. I'm thinking through that. How many thousand users? 500,000?
Lobby, one thing where when we are trying to match a player, it could go beyond, 100, 200 milliseconds, right? Because sometimes it can take a while to sort of figure it out. Like, we still want to be very fast uh, and have low latency, but sometimes it can go like up to a second or 2 seconds. Like, think about other matching scenarios, right? Where let's think of Uber or those scenarios. It sometimes can take up to a couple of seconds. So even this can ideally take up to 2, 3, 4 seconds when we are matching players up.
So the idea here then being we have multiple lobbies. That way they're different they're different sessions, but in some way maybe they then share the same memory location for all the players that are online. That way all the different lobby sessions can then work within the same can use the same memory location online to figure out the best players to match together.
Okay. Any other thoughts? Actually, where will you be storing? I want to understand the database aspect of things. How we storing? Like, what the table? What sort of database you would be using? All that.
For the players signing up and the players' information,
Yeah.
probably it. So I'm thinking through if we need to store any relationships between the players or not, other than so players will have all that information. Sessions will have the players, and then maybe when the game started, all that information. If we wanted to store the players, we could store the ID. Probably a NoSQL database, a KV style database, maybe Cassandra or a similar database.
Okay. And what would be in that database at this point?
So let me draw that out real quick. So NoSQL database. So we'll have namespaces and partitions for the users, players, game sessions, and then in here we can store whatever information for the players, like their player ID, ratings, whatever information that we need, and then game sessions, it could be game session ID, players, which will then have like the player IDs, state of the game session. Is it active? Has it ended?
Let's come back to the states and all that in a bit. Like, but I get the idea here. So now, because there are so many games happening, and we want to ensure that um that the game that is going on is we can scale it well. We can recover well if anything goes wrong, right? Like, if a server goes down and two people were playing a game, we should instantaneously be able to come up back up and allow them to continue their game. How that happen?
Yeah. So my thought process behind that for fault tolerance is to recover if something goes wrong ASAP, the last valid game state would be stored in a separate data store here, where after every single move, right, I make a move, the rules engine checks. Once the rule engine validates that move is good, we store it there. Same thing for each player after every move. If something goes wrong, we can rebuild the last state, the last valid state of the game from our game state. And then that way the players can then reconnect back and then resume from where they stopped.
So at every move, you will create a state of the game.
That overrides the previous one after the move is valid, right? So I make a move. It's chess, so there's probably a clock. Once the system accepts that move as a valid move, then I store what that state is.
And you sort of okay, and that is one game per state. Okay, and how do okay, so walk me through this process. When we are storing this state, how are we storing it? Like, where are we storing it?
Yeah, it's no different from it'll be some process of serialization and deserialization, right? Where we have our version of what the game is, right? It could be it will be the positions of the players, of the pieces on the board, and because that's the same information that's being sent to the players, right? And then they then make a move, which is a request to make a change, right, for the next state of the game. And then that's what we then send to our rule engine that says, okay, based on how the board is right now, is this valid? And then if we say it's valid, that's a move, then we store that version of that state, right, as the next new state, right? So in basically
Yes.
what we're doing is sorry, go ahead.
I'm trying to ask, like, are we storing it in a database or are we storing in memory? Like, where are we basically storing this? And
Yeah, you could store it in memory while the game state is happening, and also persist it in a more durable storage, like a database, for example.
okay, do we need to persist it? And if yes, why?
Well, in memory is very volatile, right? If the server that the system is going on is running on goes down, then um we lose all of that, right? We can't recover or we can't rebuild from the previous state. So
How frequently and how? So player two makes a move. Game session engines calls this rule engine, and it's like, okay, well, we validate this move. We add it to game. So this game state is we send the state of the game to this game state, and it adds to a cache.
to give me 1 second. We don't need the cache. We could directly store it in a durable memory, like a database, because we only read from this if something goes wrong, and it's sorry. We only read from this database if something goes wrong to rebuild things back. But as far as storing it in a cache, we don't need that. Yeah. And if we need to rebuild, we just go back to the last entry for that game and then rebuild it from there.
Okay. Let me think this through. So you're saying we'll add it to a database, and that's where we'll recover from. Okay. What happens if we have a connection of the player two that's disconnected at some point? Um, what do we do in that case if we have this database or the game state there?
So what happens if a player gets disconnected from the
Yeah.
game session? It depends. Were they if they're the one that's meant to make a move and then they don't make a move, then
No. So you know it was not there was network latency or network issue, right? And they got disconnected and then they got connected back again. that sort of, how do we recover the state of the game in that case?
So the clients themselves are not the state of truth, right? The server is the state of truth of the game. So if I disconnect and I reconnect, I'll just see the state of, like, it's server driven. So I'll see whatever the server says is the valid state, right? Which, if I disconnect from a session, that doesn't mean the session is dead. It just means my connection is off, right? So if the session itself is dead and we need to get back up, then we can rebuild from here. But if a player disconnects for some reason and they connect, they'll still see the valid live session.
Let's say. Okay. Is there a way we are storing, who is, like, the information about the session and the players? Is that in a database? Is that in a cache? Like, how are we storing it? What's going on there?
That we will store that in memory, because it's a live active session. We want that to be as fast as possible, right? We want whatever we're pulling to be as fast as possible. So we'd probably have a cache here for in-game game. No, I think it might be easier to put it somewhere else. Let's make this here. Yeah, so in-game session, and then we'll have cache, right? Active games. Yeah. So the live game sessions themselves would be stored on the cache in the actual engine itself, and then after a remove, after a revalidated move, we persist it in the database. Yeah.
Okay. Anything else that comes to your mind that, with regards to scale, ensuring that we are scaling well, whether it's the game per move or anything of that sort?
Yeah. So handling 500 concurrent users, we would need multiple instances of our. We'll need multiple instances of the game engine, obviously, because they all can't have 500 people connected to one game session engine, except if you use a very big, the biggest server, a server that's as big as my house. Even that, it's not the smartest thing to do. But we'll have multiple instances. Same thing here, multiple instances, and then
You've brought up a good point, actually. So if we have these multiple instances, right? Player X makes a move, and then it goes to instance, A or alpha, and then player 2 makes a move and it goes to, beta instance. That will add latency, right? Primarily because it's connected.
yeah, go ahead. Nah, they'll be connected to
The idea, what am I? Yeah, explain
Yeah.
that.
the same session, right? So yeah, so if the second we start an active game session, right? Those players are locked down to that specific session.
Okay, that information also needs to be stored somewhere, right? And you're storing all that in the cache active games, is what you mean, or somewhere else, or all that?
Yeah, so all of that would be stored in the so all of that would be transferred as part of the connection back and forth, right? But it'll be stored. So once the players make their move, right? There's an active connection there already. But because go ahead.
Each instance is hosting like X amount of games, and each player is all the players of each game are connected to the same shard of that instance, basically, is what you're
Yes.
trying.
Yes,
Okay.
that is what I'm saying. Yeah. So we can have a load balancer here that balances the load, and we could put the load balancer at the L4 level, actually, so it does it based on the IP instead of the packets, and then it goes directly to the server itself that is handling the game, right? The specific instance of the server that has this session for the game, because in this case we may not need to know we may not need to decode the packet and figure out what information is in there.
Great. So yeah, coming back, like anything else?
Nope. So far so good.
Perfect. Sweet. That's pretty much it. Thank you so much, Umar. Yeah, that's all the questions I had.
Thank you very much. Yeah.
Great. Thank you so much.
I'm an engineer over here working on Instagram Reels for the last couple of years. Really excited to get into this leadership round with you. Before I do, just want to hear a little bit of an intro from yourself.
Yeah, absolutely. My name is Uma. Currently a software engineer at Netflix, mostly working in the consumer identity space. Prior to that, I was at Microsoft, where I worked in a series of verticals from Substrate, Office 365, and then did some networking automation as well.
Awesome. So I might be taking some notes just to have that. I'm really excited to get into your experiences. So to kick things off, I would love to hear about a project from the last couple years, and I would like you to walk me through the complexities of it, as well as things that made you proud about this project.
So during my time at Microsoft, I worked on this very, very interesting project. I worked on basically automating policies for Microsoft's firewalls. Basically, wherever there's a Microsoft presence, wherever there's a Microsoft building, think data structure. Think Microsoft Office buildings themselves, but also data centers, right? Wherever there's a Microsoft presence, there's networking within those buildings, right? There are routers, switches, firewalls that goes in those buildings. And so I worked on a team that basically automated the process of updating the policies on those firewalls, routers, and switches. And so, as you'd imagine, it was very involved in that. First, it wasn't just one region, right? It was all over the world. So the system that I built worked on updating those policies, but it couldn't just do it all at once, right? You couldn't upgrade all of North America at the same time, because then if something goes wrong, then you have that problem. And so the steps to doing that was, first, I worked with the networking engineers who own those devices, set up regular meetings, understood the domain, understood the space, understood if what we're even trying to do was possible in the first place, right? So turns out it was, but we needed to do some work to standardize how they were doing things before we automated, because you can't automate without standardization, right? So we worked with them to do that. They ran all of those on their firewalls, where they went through and they renamed most of the policy to fit the new way we're going to do it. So if they used to name like an IP object a certain way, they had to change that. So the next time we're running an automation to go check if that IP policy already existed, it was a standardized way instead of just having it be different. So did that, and then after that, worked on this engine that basically took the policies that people would want to update and broke it down into multiple steps, right? First, it created the objects, then it applied them to the firewall engine themselves, then it pushed it out to all these regions, then it tested that the policy that it has pushed out is actually working, is in place, and then after that, it then closed the whole flow. So it was a process that basically took updating these policies from around 4 days, because of how involved it was, to around 15 minutes, right? So before, there would be a person in the loop to basically have to do all of this updates, right? They would manually have to log into the firewall versions, do it, push it all into all these places. But the system that I built basically took that process and took the person out of it and just automated the whole thing to around 15 minutes.
That's really, really neat. It sounds like you were like pretty cross-functional in this one and working with a lot of different teams. Can you give me a little bit of kind of understanding of the scope for like how many different engineers were maybe impacted by this really cool automation?
Yeah, absolutely. So the way it worked is I worked with the teams that own the firewalls themselves, right? But the way the firewalls worked, where there were different regions, so you could have a team that owned the firewalls for these regions. You could have a team that owned the firewalls for these regions, a different team that owned the firewalls for this region. At the time, they were called service lines, actually. So you have all these different service line owners, and so across three to five different service line owners. But I think what was also interesting is within all of those, there were different models of different systems, right? So this team liked to do things this way, this team liked to do things that way. So that was the complexity across working with like different things, right? Basically, being flexible enough to kind of like hear how this team is doing this and maybe potentially change my approach, or also going to them and saying, hey, I know you're doing things this way, but this team is doing things this way, and I think that with their way, basically helping them see the value in doing things that way, that could help them, but also help me at the same time, right? So there was a lot of cross-functional stuff happening there. Yeah.
That sounds really cool. I want to touch on the cross-functional stuff again in a second, but first, what about this made it like proud for you?
Yeah. So I think as software engineers, we mostly write code, and depending on where you are on the stack, you could you could hardly see the direct impact of your work, right? So typically it's like, yeah, I made this change that did this thing, but then I'm so down on the software stack that the users who are using this are interacting with maybe 3, 4, 5 services above me, and the small change that I'm doing is so minute in the grand scheme of things. But this wasn't that. This was hey, where the networking engineers would have to manually go in and make these things, right? It was actually something that people on call would do, and so people didn't like being on call for that because they would have to then go do this stuff manually, right? And so what made me really proud of it was, just going from a situation where going on call was a dread because you didn't want to do this, to now saying, oh yeah, like on call now all I have to do is just do whatever, like do less of the manual stuff that I don't like to do, right? And to the final point there was, I genuinely loved the output itself, right? Which was 4 hours to 15 minutes, right? The errors also went down, right? Because when you have the process automated, there's less room for people to go make a mistake when they're creating a policy, and then someone then reaches out and say, hey, this thing that you did for me that you said is supposed to be working is not working, right? But if we added, we added that check in the whole process, right? After we've created this policy, can we verify that this thing actually works the way it's supposed to, right? And so, seeing the direct output of my work was what made it really, really proud for me. Yeah.
That is really, really neat. I can hear your passion as you're saying that, and a lot of people can relate to an on-call situation being made easier. So, engineers everywhere jumping for joy with this kind of thing. Was there a particular technical gotcha that you thought was interesting to you? Maybe one that had multiple solutions that you could have gone with, but one that you ended up choosing? Could you talk me a little bit through your decision-making process?
Yeah, absolutely. So there were so many points in the project where you had to choose, where I had to choose between either, I'll give you an example, right? How is this service going to run, right? You can have it be smaller services within like a microservice architecture, right? Where once this step of the process is done, it calls this step, then this step is done, then and then it does that. Or you could have it just be one system that just goes through the whole flow, right? So if you have it be one over the other one, right, what are the trade-offs there? If you have it be one system, the second the service is down, everything is down, right? Like you can't process things in batches, right? If one part of the process is taking a very, very long time, which actually happened, then the whole thing stalls, right? If you have it be smaller micro services within the whole system, then what then happens is you can scale each one individually, right? if there's more processes that need to run for the step where we clean the input, for example, we can create, we can have policies where it scales based on the amount of messages in the queue. For example, I actually use the queue system, right? And so there were decisions like that that had to be made, right? There was also different ways to say, okay, how do we connect to the panorama, which is the instance where we made the change? Do we want to connect to it via an API where we just call an API, but we would have to expose certain implementation details that we didn't want to, or do we want to call it via an SDK? They had an SDK in Python, right? So we ended up using that, but there were like all these decisions that had to be made, and through processes like that, I typically just think through saying, okay, there's no perfect way, right? There's obviously a way that will mess things up. You definitely don't want to do that, but you essentially want to trust your engineering judgment by gathering information, right? What do I know? What do I not know? Reaching out to people who have experience with it. In a lot of cases, myself, I typically try to create a small version of it and experiment, right? If I have time, I try to create a small version and say, okay, what could be the problems with doing this way? Because when you have it in your head, it's just theory. But if you have it in practice, you see the code, you're like, oh yeah, that is a glaring problem, right? It should not be that way. And so that's typically what I like to do whenever I have technical decisions to make around software design.
That makes a lot of sense. And what you're basically kind of filling in there on the color is like one of the lessons that you learned and how you've now changed your approach in the future, which is great to hear. One thing that I would like to know is this project. If you were going to go back and do it again, what would you do differently if it, if you were going to do want something differently?
It is a good question. So the part that I mentioned around working with the different teams, it was kind of hard at first because the approach that I went in with was, hey, this is this really, really cool thing. Let's do it, right? And people don't usually like to be told what to do, if that makes sense, right? Like, there's a way you can approach conversations with people where it's actually a skill you learn where you frame it as the benefit for them, right? And if you tell them why this thing is good and come in terms of saying, hey, this is this thing. It's just a thought that I have. I think it'll be beneficial for you this way. But yeah, just let me know the ball is in your court, all that stuff, right? Even if it's something that you want to happen, right? If you approach it with, here's how I think this thing can help you, right? And this is why I think you should go into it. It's much, much better than the way I had originally done it, which was, hey, we need to refactor all of this. Like, basically, I went into it with, you guys need to do all this work, right? And then I eventually learned that when they learned that, oh, I don't have to do this on call anymore, right? I don't have to, the framing around the benefits of it was much, much better to them. And then people were actually happy to hop on board and help me do all of that work, right? So it's all about like the framing. And so typically, that's what I would have done differently, because I think it would have helped smooth some of that bumps that had happened at the beginning.
Yeah. I mean, talking about getting buy-in and learning different ways to navigate that over time is it leads really well into something you brought up earlier as well. And like this idea of whether it's on this project or another project, you're interfacing with different teams and you need to get their input. And I'd like to hear about a time where you were basically getting inputs from different senior leaders. And can you just describe what that collaboration process was like and how you all came to like a final agreement on the approach? Again, could be this project, could be a different one.
Input from senior leaders. Let me think. So my time my time in Substrate, I worked on a project called FileScore. FileScore is essentially the files ingestion layer for Substrate. So if you've used OneDrive, SharePoint, Outlook, of any Microsoft 365 product, your data lives in Substrate, and the way data gets ingested into Substrate is through the files APIs. And so at the point in time, I was working on migrating a few of the endpoints from one service to another one, right? Just so I can abstract all the details. It was a lot more complex than that. But the technical approach for how to do that was the contention point. So there were two ways you could do it, right? The migration of the APIs weren't one-to-one, if that makes sense. So there were things that were available in this new service that weren't available in the old one. And then there are things that are available in the new one, but have to be done differently. So what I was essentially doing was rebuilding this thing from the ground up. And so the approach there was saying, okay, do I want to start from the bottom up where it's like, okay, at the end of all of this process, I want a file, right? So I start from deconstructing the old API, starting from the simplest layer, right? I want this file object, and then going up. Or do I want to start from up top, which is to say, okay, there's all this data that comes in with the file, right? There's all this information that goes through. There's filtering information. There's who you've shared the file with. There's all this stuff that still is needed in the API, right? And so the contention there was what was the best way to go ahead and build this in the limited time that we had. And so I had discussed with my managers, I had discussed with the SME at the time, who was in charge of the project. And my approach was to start from the top, right? To say, okay, let's figure out, okay, for this version of this, what is the equivalent in the new API? For this version of this, what is the equivalent? And then his approach was, if you do that, then it'll take you a lot longer. Why don't you start with the simplest approach, right? Write whatever you will need, right? Mock everything, right? Create dummy fields for everything, and then get the file. And then from there, you can then start filling things out, basically. And so, that was how we kind of like worked through that process. And eventually we got to a point where I used his method, which was to mock things, and it took longer, but I understood the system more, if that makes sense. So because once you've mocked everything, you kind of figure out, okay, this needs to go here because of this needs to go here because of this, as opposed to just trying to copy what was in the old system and put it in the new one. Yeah.
That makes a lot of sense. I think the thing that one of the notes that we haven't talked about yet is, and it's something that comes up all the time, is conflict up the org with your manager or a skip level. Can you think of a time where you either had a conflict up the org chart, or even that you were gonna have one but you were able to avoid it? Either one.
Most of the conflict that I've had up the org charts typically relate to technical approach. So during the project that I worked on, which was the firewall policy automation, there was a point in time when we needed to try a new approach for that whole project. And the plan there was to, it was a very, very simple conflict, actually. I suggested, hey, let's get a new repo, get a new service, just start everything afresh. And my manager at the time was like, you can definitely do that by all means, but the reason, like, some of these structures exist so that you don't do that, right? So in Git, you can just, work off a completely new branch. For the place where you deployed it, sort of creating a new service, you could create a separate cluster and just do your work in there, if that makes sense. And so I wouldn't call it like a serious conflict. It was more of a suggestion than a conflict. But at the end of the day, the decision was in my court, and I ended up actually doing a mixture of both. So even if I created a new cluster because of the way things were set up, because he didn't know the nitty-gritty details, the existing cluster would have still interfered with the main cluster because they shared similar resources, right? But for the code, it made sense to put everything in one place, so everything related to the service lived in a single repo. So in situations like that, and with like conflict with people who are either your teammates or people up the chain in general, I think what I typically do is understand where they're coming from, right? Understand what information they have that I don't have. At the end of the day, it's never an attack on me, right? I think a lot of people see conflict as an attack on their personality, on their work, on their stuff. People typically don't mean that, right? It's just hey, try to think of things from a different perspective, right? Try to put yourself in their shoes and eventually come to a resolution that works for both parties. Yeah.
Absolutely. Absolutely. Sounds like another lesson in there too, just taking that forward and learning how to take that to other conflicts. Yeah, really neat. What about feedback? Can you think of any feedback? Maybe it's a theme in your performance reviews over the years, or maybe it's a particular point that you got feedback on. But ideally, I'd like to hear about something that's maybe critical, and maybe just kind of walking through what the feedback was, how you ingested it, if you agreed with it or not, and then what you did about it. And yeah.
Yeah, absolutely. So so there was a point in time when I was working with a PM, a product manager, on a project, and I had I kind of owned my own part of the project, right, which was the backend implementation, and then a separate group of people owned the front end part of the application, making the changes in the UI, right? This was while I was at Microsoft as well, and what would happen would be we had customers that were using the product and we had to ship, right? We had deadlines to ship. Now, I was working with another engineer for the back end, and then there may be 2-3 engineers on the front end. Whenever there was a task to get done on the back end, we would always get our things done straight and narrow, right? Hey, this API is this integration is due on this date. We know we have a release on this date. We need to get it done on this date. We would always do it. The front end group were struggling a bit, where they would say they would get it done on this date, but things would typically fall through the crack and it would kind of like fall last minute, and it happened one too many times. And so the feedback that I got from the PM I was working at the time was very, very good feedback. She mentioned, hey, you're doing your part right. Everything is doing like you're doing your part right. But in the context of the entire project, it's not looking good, right? Because even if your integration is working properly, right? The UI part, which is the part that people integrate with, right? Like your part isn't complete without theirs, right? So what's happening is there's this vacuum where there isn't like a strong leadership within that project, where it was just two people working on separate parts, but there was not one person who had stepped up and said, hey, I own both of them. I will make sure this part goes well and then this part goes well, right? And so as soon as she gave me that feedback, I automatically assumed leadership for both, right? Instead of just saying, hey, my part is done right, absolutely great, right? It's almost that idea of, like, it's almost that idea of basically owning the whole thing, right? And being responsible for everything, as opposed to just saying, okay, this is just my part, right? So it's called unusually responsible, right? Where whether it's mine, whether it's not mine, I will own it until I find someone else to give it to who will be responsible for it, right? So not seeing anything that basically that isn't meant to be a certain way and then just saying that's not mine, right? Or that's not my situation, right? Like it's the next guy's problem. So that was the feedback that I got, and that's how I basically applied it, where ever since I got that feedback, wherever there's a vacuum to lead, wherever there's a vacuum to say, okay, so someone needs to be in charge of this thing, even if I have a lot on my plate, I typically take the responsibility to own it until someone else wants to take it from me, or until I talk with my leaders to decide who might be the best person to own it. Yeah.
Nice. Super helpful context. Can you think of a time where you had competing priorities and there were multiple projects that you could work on, but how did you end up choosing the one that you chose?
Yes. Competing priorities. I think that basically happens all the time, right? You're always juggling multiple projects. Let me think of a concrete scenario. So not similar. When I was during my time at Microsoft, there was an initiative called SFI, Security First Initiative, where we basically dropped everything we're doing to focus on security. Meaning whatever project that you thought you were working on, it didn't matter. Drop everything and go to this dashboard that will tell you all the problems that are wrong with your services that aren't secure in some way, and then you need to work on fixing them. Some of them were very simple stuff from, you need to put your secrets in this place and like rotate them every X amount of weeks. And then others where you need to rewrite this whole thing because, it's not written this way. And so that was happening at the same time as me having projects that I needed to deliver, where there was a tight timeline that couldn't be moved. And so the directive from above was to drop everything that you were working on and kind of like pick this up. But at the same time, when you have customers, when you have people that are relying on the service that you build, when what you're building is a tier 0 service that can go down, it's almost like you have to take information like that with a grain of salt, right? And essentially use your judgment to figure out what's best for the business, what's best at that point in time. And so what I did there was, for those two things, I definitely had to do both, but in the context of when certain things were due and which the most, and I basically prioritized things based on when certain things were due and which would require the most effort. So if I knew that, okay, this security first initiative this security first initiative task is very, very big, but it is also very important as well, and we need to get it done before X amount of day, right? I would kind of like I would basically prioritize that, but in the context of also this other work that I have for this team, right? And so the idea was then saying, okay, how do I balance both of them, right? I could still make sure work was getting done and not do the work myself, right? So making sure I delegated to the right people, right? Reaching out to my manager and say, hey, I need help from here. I need you to help me get 2, 3, 4 people that can help to do this. And so maybe influence how they're doing things or make things a lot easier for them to get that done faster while also making sure things are being done on this end, right? So typically with prioritizing multiple projects, I always go back to, there's this chart. I always have it in my, I always have a mental model. There's like important and urgent, right? Not important, not urgent, urgent and important, and then not important and not urgent, right? So once you kind of like put things in those quadrants, you can basically try to say, okay, I need to get these done as fast as possible, right? Or these are very, very important, but they may not be due now, so I need to have them in the back of my mind, right? These are not important, these are not urgent, right? So maybe this can fall through the cracks, because the reality is some things will have to fall through the cracks. And then for other things that are important, but I've lost track. For a certain group of things, there are things that have to get done, but I don't have to be the one to do them, right? So how can I help influence other people to do them as well? So that's typically how I think of prioritizing things.
Thank you. Thank you for the context and the stories. Those are all the questions that I had for you today. Uma, thank you very much for your time.
Appreciate it. It was nice talking to you. Thank you.
And we are glad you are here. My name is Daniel. I'm currently at Meta for the last couple of years, working on the backend, distributed systems and all that sort of team. And, I'm really excited to interview you And yeah, I would love to sort of we'll go through a coding round. We'll have a couple of questions, but before that, I'd love for you to introduce yourself.
Yeah, absolutely. My name is Uma. I am currently a software engineer at Netflix. Prior to that, I was at Microsoft for around 5 years. I'm excited to be here.
Sweet. Let's get started. Just an overview. It will be a 40-minute interview process, and we'll have like a couple of questions for you. And if there is more to happen, I'll let you know. But that's just a rough estimate of what and how things will go.
I'm good.
Do you have any questions before we get started?
Nope, no questions so far.
You have the quarterback link.
Yes, I see it in the chat. I will open it and begin sharing.
This is the question that we'll go through. The idea is we want to remove minimum brackets or parentheses to make it a valid string. There are some examples given. Take a look. Let me know what your thoughts are if you have any questions, and then we'll get started.
Okay, sounds good. So I will read through the problem and get back to you in 1 minute. So minimum remove to make valid parentheses. You're given a string S that contains lower case letters and 2 types of brackets. This is a type, this is a type, and this is a type. The task is to remove the minimum, so the smallest number of brackets, so that the resulting string is valid. Rules for eligibility. Every opening bracket must have a matching close bracket. So it has to be a matching closing bracket of the same type. Brackets must be properly nested. Letters should remain untouched. Return any valid string after removing the minimum number of brackets. And then these are the examples. Here's this. And the output is... So I've read the problem. I think I understand it. I want to go through the examples with you in real time just so I have a better understanding of what the problem is asking. So this is the string that we're given, and in this string, there could be a combination of these types of brackets. And my response, so rather the output of the function I'm supposed to write is supposed to remove the smallest number of brackets so that the resulting string is valid. And the rule for validity is every opening bracket must have a matching closing bracket with the same type. So if it opens with this, it must close with this. Okay, similarly with this. Brackets must be properly nested. Okay, so in this case, this is nested within this. Okay, and the letters should remain untouched. So we don't want to modify any letters in the string. We only want to modify the brackets itself. Okay. Return any valid after removing this. So going through this example, the output of this is here. So we go through, there's A, there's this. So in this case, we removed the 2 invalid closing brackets at the end for it to be valid. And then in example 2, okay. So we can either return this or we can return this because we could, I'm trying to wrap my head around this one. Okay, so if we remove these 2, so this one and this one, then we can return that valid string. And then if we return this 2, we can return those ones we can then return those 2 as valid strings. Okay. I want to go through one more example just so I have a good understanding before I come up with what might work. So I'll just copy this and then, there's another example down here. Okay. In this case, there's no way for us to return a valid output. That's why the output is an empty string. Okay. And finally, so if I had something like this, for example, then the output would be, we would have to remove this, but then we'd also have to remove this. Then we'd have to remove these 2 as well, and this would be the output. Is that correct?
we would have removed 3, right? Yes. So we removed this and remove. Yeah, that is correct.
Okay, so that's the minimum. Okay. So the rules here says that we can't touch the characters, right?
When
In this string.
we are trying to maintain the order of the characters. That's
Okay.
basically what it means.
Okay. So we're trying to maintain the order of the characters. So going back here, I'm thinking about the rules for validity, and with brackets in general, first you want to start with an opening bracket, because a valid sequence can't start with a closed bracket, right? So that's something to keep in mind. But then we also want to figure out when to close, and we also want to remove as well. Okay. So I'm thinking through a solution. So since we want to remove brackets, I'm thinking of rebuilding the string, but then just removing items when we don't need them anymore. So a process that would go through every single character in the string and then figure out whether we want to remove that item from the new string we build, if that makes sense. So for example, in this case, we'll start here, A. We want to keep the index of A. Sorry, you had mentioned something earlier to say we can move the indexes as long as they remain in the same order, right? Okay, perfect. All right. So we can start here at A, and A is not a valid, A is not something that we can touch, right? We can only touch any of these 3 brackets, so we're going to ignore it, and we go to B. Now we're here and we're at the closing bracket, right? So if it's closing, we know that we have to remove it because, well, so there's 2 ways to think about this. If it's closing, right? Let me actually start writing this down. That way I have a pseudo code by the time we're done. Okay. So for this one, for example, so we iterate through. I'm just writing the pseudo code here, by the way. I'm going to write the main code after. Iterate through string. If we get a closing bracket of any type, so if we get the closing bracket that is like this, or of any of these, what I can do is it could be valid if there's a corresponding opening bracket that have been created for the closing bracket that we come across. And the way we check that is through a stack. So as we go through the items in, we would simply add it to a stack. So if we come across an opening bracket, it doesn't matter what it is. So it could be this one, it could be this one, or it could be this one. We'll add to a stack, right? And if we then come across a closing, we will then check if the item on top of the stack is matching the closing one, because then that would be a valid pair, and then we would then remove those 2 from our string. That's the first case. So that would cause that we're now going through. So in this case, if we come across this, we would add it to our stack. Then when we then come across this, we'll then remove this from our stack. That way we know everything so far has been valid. Same thing here. At that time, we would have added this, and then would have added this guy, and then same thing on this side. The question then comes when we see this and there's nothing to close. So we want to remove this, and we want to do the same for this. So since we want to remove this, but we want to keep everything else that's normal, we could simply just keep track of the ones that are the indexes of what we want to remove. And then that way, when we then go through the string the next time, we just remove them. We just add the ones that we don't want to add back in the string. Does that approach make sense?
Yes. One quick thing is, what happens if we have something like this?
Like this.
Mm-hmm.
So in this case, we would add this to our stack. Then we would add this to our stack again. Then we would add this to our stack. Then we've come across this. Then we'll remove this. Then we'll come across this. Then we'll remove this. And then at the end, whatever will be left in our stack is also an index that we have to remove because there's no corresponding closing for it at the end as well.
Sure. Yeah, that's good.
Okay. Would you like me to start writing the code?
I agree with the approach. If you're comfortable writing it out, let's do that.
Okay, sounds good. I will write a method called remove minimum. So we want to take in a string and then return a string. So public, let's make it static in case we want to test it. String, we're returning a string, so remove minimum. And we're taking in a string that string input string. Okay. So the first thing we want to do is we want to go through and create a map for this. That way we just quickly correspond the input to the output. So we'll say hash map, say brackets is equals to new hash. Oh, we have to just the type string, no character. Okay. No character. Yeah, hash one. And then what we want to put, and then we'll put the brackets. Oops. So we do bracket brackets. Oh man, opening. So this way we just refer to the map to know where the closing and opening is for each one. So we'll do this one and then this one. Okay. So next I want to create our stack that we'll use, but this time we'll use a stack of integers since we're storing the index of the items that we want to remove and not the actual character themselves. So integer brackets is equals to new stack. Then when to then do not brackets. Let's say bracket indexes. Okay. Then we'll do a for loop. So we'll do for int I equals to 0, I is less than input string dot length I plus plus. So the first thing that we want to do is we want to check if input string at I is equals to if it's equals to any of the openings. So this or Let's move this way. This. Sorry. Char at I. Okay. Should be like this. So if it's any of these, then we simply want to add it to our, we want to add the index of that to our stack. So add I. And then otherwise, so we've come across an opening. Let me pull this down here. Just so I'm going through it in real time as I'm writing the code. Okay. So we've come across an opening. We add that opening. Otherwise, if we've come across a, so if it's any of these, otherwise so we want to also factor in that it may be an A or a B or a C. So if it's not an opening, then it may potentially be a closing, meaning if we get whatever we get from our brackets here, so if brackets dot get object, and then we want to get the character itself. So if we get that and is not equals to null, meaning it's a closing. If it's not equals to null, then I do this. So if this, so if I get this and it's not equals to null, means it corresponds to this. I then want to check what's at the top of the bracket. So I want to do a peek. So and top is equals to sorry. So something that just came to mind is there might be something like this. But I would still need to remove these three.
Not really, right? Like, because you can remove one, two, yeah, so three of these, right? So this and this, or you can remove the first bracket, the third one, and the fourth one. It depends on what you want to remove.
Yeah. So I want to check if the closing matches, then I take it out. If it doesn't, then I still leave it. And then everything that's left in, no, if the closing matches, then I leave it. No, then I take it out. Otherwise, if it doesn't match, then I put that index in. Okay. Top is equals to string. So this is the character here. So I get input string. Oh, I want to get the brackets. So get a peak. So this is going to give me, and then not bracket indexes. So this is going to tell me okay, it's going to tell me what's on top, and what I then do next is I check so I then want to get the top of, so I've gotten the top, then I check brackets. If our brackets dot get the current input string, I'm using this a lot, I should probably put it somewhere, right? If it is equals to yes, if that is equals to this, then I want to pop. I want to remove whatever is there, meaning it's a valid thing. Otherwise, else it's not valid. Then I want to add this to, I want to add I. Okay. So this is the first step, which will basically help us build our stack. And then we essentially then want to remove all the items. So we now want to rebuild the string, and then any item that is in the stack, we want to not add that to our string.
Okay. What about, so a few things, right? Like first, what is happening to this use case?
Yeah. So in this case, let me walk through this before we do that part. So in this case, what will happen is we'll start with A. A is not any of the input string, else if we do brackets dot get A, which is going to return null. So we're not going to go in here, and then we'll then go into this guy. And now this is the closing. So it's not any of these. So we'll do brackets dot get I, brackets dot get this, right? Which
Will return is this.
yes, is going to return this. And then we'll try to get the top of this, which would be
Have anything in the top.
which would be null. Yeah. So we also want to do a null check there. So if top is not equals to null, and put this in brackets. So if the top is not equal to null, and
It's fine. We can come back to it in a bit, but let's logically go through this. So if it is not null, and we have found something, that means it's a valid bracket parenthesis, and we close it out, right?
yes,
Otherwise, we add it.
we add that index. Yeah.
Okay. So stack is basically keeping track of all the all the brackets that are either opening or incorrect.
Yeah. So if it's an opening bracket, right, we will add it. Otherwise, if it's a closing bracket, we'll check if the last thing that we added to the opening bracket is if the top of the stack is what we can use to close it, right? Then that would mean it's a valid pair, and then we then pop it. Otherwise, if it's not a valid pair, it means we have to remove that in our string. So we add it back to our stack, and then
But
at the
but
end, yeah, go ahead.
I'm at line number 100. The issue there is if we have something like this, right? We have this and we have A, and then we have this. So we added to our stack, we skipped it. Now this is technically an invalid bracket.
Yes.
So we still added it to our stack. And when this comes, the last thing that we look at is this particular bracket because we have added it to a stack.
Yeah, that's on the top of the stack. Yeah.
So the ideal answer should be A, but based on what we have, we will what you have is we will probably skip.
Yeah, based on what I have, we'll add all of those indexes, and then we will then return only A, and that is not valid. That is a good point.
So I think if we can separate the two, the stack and the invalid, things, that might be helpful. What do you think?
Yeah, that makes sense. So we only use the stack to keep track of the validity of the braces, and then we use a separate data structure to just keep track of the indexes that we need to remove when we found an invalid use case. So, okay, that is a good call out. I'll use a separate list for that. So the list of integers, invalid indexes, equals to new array list. Into there. Okay. So once we found here, we'll just add this invalid index dot add I. So we don't add this anymore. And then we'll then use the invalid index is to then build our string again. So we'll essentially then go through our string and rebuild it if for the indexes that are not in our invalid indexes. Okay. I will use a string builder for that. So string builder is string doesn't mean so for not for a loop for and I was 0 while I is less than we'll just use our input string again. I plus plus. If I, which is the index, so if our invalid indexes does not contain I, then we want to append our new string dot append input string the string dot length append input string dot char at I, and then we should then be able to return our new string. There's an error here. The operator is undefined. For the argument type, no. Top is an index.
I think does peak always return null or will it return -1 if the object doesn't exist?
I think it'll return null looks at the top of the stack without removing the stack, returns the top of the stack, and it throws.
Stack exception. So that's probably it. It will return an error. If you click on peak, it will show you that. If you click on peak, it will show you. It will return an exception. So I think we can't have an exception, and that's why it's giving us an error.
Okay. So I can set up. I can have the method throw the exception.
But then we won't be able to continue through the algorithm.
Oh, this is for, okay, I can check if I can do another check. Here. I can check if this thing is not empty. So I put this top. Do I use top here? So I can check if okay. So if it's not empty, and then I do not use this for any other thing, so I do not need this.
Wait, so how do we know what element are we looking at? So we still need to compare the brackets, right?
Yes.
So there needs to be somewhere like top here.
Yeah. So brackets dot get. So if it's not empty, and then we're looking at the top. Okay, so get the index input string dot chart. This should be the top. So we're trying to expect a closing, so it should be this one. This should be top. Yeah.
Okay.
But then this can return null. But
we can have a null like empty check here before we get to the top.
yeah. So if brackets not null. And
No, I think even if it is null, we still want this condition, right? Because we could face the closing bracket without having an opening bracket. I think better way would be to add a null check here, like empty check here.
Mhm.
And then if it is empty, then add it to invalid and continue, and don't go bottom. Or it depends on how you would write it.
Okay, yeah, that makes sense. Let me do it that way. If our brackets is empty. If our brackets is empty, and I want to add our invalid indexes here, then we continue. So we go to the, because we've already processed this. Otherwise, if it's not empty, then we add it here. Okay.
Could you tell me about the time and space complexity?
Yes. So the time complexity is, let me find the, so we're starting an input string and we're iterating over the string. And for each one of those, we are simply performing linear time operations. Time complexity is big O of n. We're also using a string builder here, but the operations that we're performing is in relation to the size of contains. Yes,
Invalid indexes is a list.
it's an array list. Yeah.
So when going through an entire string, you're also looking at this. So this will be a linear operation itself. What you don't have to code this out. What would be a good way to because this will make it O of n square.
Yeah, that's alone is n squared in this. I could use a set.
That's fine. That would be the correct way to go about it. So what I want to do is I want to get into the next question, and then we will jump from there. I'm going to write the question at the bottom of like at line number 143. You can adjust however you want um, to go about it, like where you want to write the solution. So we are building like a finding the largest element in a stream of numbers that are coming to you. You can think of like there's some data being produced, and sending the data, and you want to find the largest number at every instant, or the third largest, or whatever the kth largest number in that case. So we are given a nums array, and we want to find the kth largest number. It could be third, fourth, fifth, whatever we want to plan. In this case, what we are trying to do is we are trying to add 3, and k is 3, so we are trying to find the third largest. We add 5, and again, k is 3 because we are trying to figure out what is the third largest number in all these situations. So that's what we'll, as the string grow, we want to find a specific particular largest number every time we add a new number to it.
K will always be. I have a question about K. Will K always be smaller than the size of the array, like the size of the stream?
Yeah, k will always be valid. So that means if there is one number only, then we will maybe ask 1. We won't ask 2 or 0. So k will always be valid. We can assume that.
Okay, and it's a class that we can then add these items to it. Gradually add this, add this, add this. Okay. The first thing that comes to mind is to basically find a way to keep these numbers sorted as the inputs are coming in. That way, we always know what the kth largest number is. It'll always be at the kth largest number will always be at the index of k, of the size of all the numbers minus k. Does that make sense? So if they are in a sorted order, so if we have something like this, okay. So if this is sorted and we have 2, 4, 5, 8, the third largest number will always be at the index of k, nums minus k, which in this case is 1, 2, 3, 4, 4 minus 3, which is 1. So 4 would be the largest number. And then when we add another one, if we add another 5, is the kth largest the distinct, like the distinct number, or what if they're duplicate numbers within, like in this case?
Even if they are duplicate, so this is just in either way, this is the same answer. But even if they are duplicates, like let's say you have 4 and 4, right? That's what you're referring to.
Yeah.
The answer would still be 4, right? Like it wouldn't matter.
Okay. Yeah. So if we kept it sorted, then we could always find the kth largest number here, but then sorting it is, oh, that's interesting. Okay. We could build some sort of data structure within our class that as we add the numbers into the class, maybe sort of like a binary tree, but the thing with the binary tree is we won't know, we'll have to search each time as opposed to knowing each time. We could use we could use a heap.
Okay.
Yeah. So wait, give me one sec. Yeah. So if we use a heap, we would want to know the kth largest. So a max heap is always going to return the smallest one on top. But then, well, if you pop from a max heap, you return the smallest on top. But if we use the mean heap, then the mean heap is only going to store the largest numbers within the heap itself, but then we have to figure out a way to limit the heap to, so if we limit the heap to size k, then the top of the heap will always be the kth largest number as we add elements, but we will always have to remove elements whenever the size of the heap is more than k.
Yes. Yeah.
Good?
Yeah.
Okay. Sounds good. I see this is in Python. Let me do it in Java. It'll be 2 classes. Okay.
We can move that back. Yeah.
Okay. Solution 2. Let's do class solution 2. That way there is no solution already defined. Okay. The methods that we want to support is add and what else?
So add can always return us the kth largest.
Okay. So add will always return in the large. Okay. So we want a mean heap, which would be in Java it's a priority queue, so an implementation of a priority queue. So we would say priority queue of integers is equals to, we'll call it our mean heap. Is equals to new priority queue. It's a mean heap, so we don't need to add the comparator. No, best if we just do it in this thing. When we create an instance of the class, relation real quick. 2. We will say this dot main heap is equals to this priority queue, and then we pass in k. So in k like this. I want to see how you did that. Yeah, so kth largest, you pass in k, and then you pass in nums, which is this initial size of the array. So we'll do this int nums. Okay, so once we initialize that, we want to then add all the elements in nums. That way we keep the priority queue to the size of num. So I'll do it in the constructor, but ideally I would in actual this thing, I'll put that in a separate method I can call. So for int I equals to 0, we keep going while I is less than nums dot length I plus plus. What we'll do is if, well, we always want to add to our heap first in case the number that we add is the kth largest one. So this dot main heap dot add nums at I, and if main heap, if it's greater than k, that size is greater than k, and I main heap dot pull. So I remove any element. So right now, by the time we initialize this, the heap will have the top k elements, the top k largest element, and then whatever is in the top of the heap is the kth largest element. So once we now implement our, not in the constructor, our add method, we can do for a public int add, and then it's taking an integer, and then call it nums, and we will so we'll add it. So this main heap to add nums, and then we'll then return this main heap pull. Okay. So let me just
Let's look at this thought again. So if we have, in our bin heap, let's say we have 2, 4, 9, and we added 5, what would happen?
So we've added 5. What will happen is our main heap is going to temporarily have 5 is going to come here. So it'll be 2, 4, 5. Like this, and then we're then going to remove the kth largest element, which would be 4.
But we still have 2 in our heap.
Oh, okay, yes. So I need to remove. Oh no. I need to check the size of the heap first before I add or I remove elements. So if heap dot not heap mean heap dot size is greater than or equals to, if it's at k equals to k, then I want to remove an item in the heap. So for the adding, you would like the behavior should be giving the kth largest element in all of the solution, like before it's added or after it's added?
After it's added.
After it's added, okay. So in order to add it, then we need to kth largest and kth largest is equals to so if it's equals to k, it means the kth largest right now is whatever is on top, meaning we need to remove it. Dot peak hole. Sorry. So this is the response that we will return after adding 5. So we need to do so we need to check if it's the size. We remove it. You want to take into response. To this, then we add it to our heap. So we'll say that. Like, sorry, give me 1 sec. I'm trying to think through the order of operation. So
I would just point out this part, like the way you have done here, always a similar logic.
okay.
Like basically we are adding a number.
Okay. So we'll basically add this, and then if it's greater than k, then we remove whatever is there. So we'll do main head dot pull. do return. Okay. So okay, you already said it'll always be within K will always be within the bounds of what we're given. Okay, so this makes sense. And I was thinking of a case when K might not be. Okay, this should work.
So let's walk through this again. This example. What will happen? We have this heap. We add 5. 5 gets added. This is the top of the heap. And you return 2.
Wait, give me a sec. So this is it. 5 gets added. So and then I return 2, but then the third largest is 4. So I should return 4. So I pull and then I return the peak after removing the element. Yes. Well, and what's that name? So this would remove this since it's greater than the size, and then the return would be whatever is now on top of the heap, which is this.
We should move this outside of if condition. I mean, in a case where we I think this should work now. So if we go out of bounds, like if we go greater than K, we pop it out. Otherwise, we keep whatever it is. And we return it. Sweet. What would be the space and time complexity?
Space would be, so at most we're storing K elements in our heap, and then we're removing. Whenever we add, we're only storing space. So that would be big O of K, that's space. And then time would be, let me make sure. Yes, so mean heap, yeah. And then time would be, every time we add to the heap, we run heapify, which I believe is log K, since we're only running it on K elements at most. Yeah. So big O of log K for time, and then big O of K for space.
Great. That would be pretty much it. Thank you so much for your time, Uma. It was great collaborating with you today.
Thank you. Appreciate it.
My name is Cami, and I'm going to be your interviewer today. I've been at Meta for about a year. Can you tell me a little about yourself?
Yeah, my name is Uma. I am a software engineer at Netflix. I've been there for around 2 years.
Very nice. All right. Well, the problem we're going to do today, I sent it to you ahead of time to pull up on your local IDE. You're allowed to use AI to assist in solving this problem. So whenever you're ready, feel free to share your screen and we can get started.
Okay, sounds good. Let me know when you can see the screen.
I can see it.
Okay, awesome. Okay, I will go through and just read the query, read the README, and then basically try to run it locally first before then understanding the problem and all of that. So, okay.
Sounds good.
Yeah. Okay. So more Java maze game. The maze game says E for exit, L for open walls, open spaces. So you can move up, down, left to right, prerequisites. Okay. Oh, let me try and compile it first.
All right.
And make sure it runs before do all of that. So this is the compile step. Okay, that works. So the class files have been created and we can run. Okay. So I ran it and it looks like there are a couple of failures on the test run. Okay. I will be using Claude specifically. So go ahead and open that and Yes, I trust this folder. Okay. These are the tests. And then there's the thing. So first thing I'm going to do is I want to get a full context of the code base. So I'll ask Claude to explain the entire code base to me, specifically what's going on, how it's important, and the different aspects of it. So I will go ahead and do that. So explain the entire code base to me, specifically what it's doing and the most important critical parts of the code. I want to understand different aspects and the flow. Okay. So while it's doing that, I want to go into the test. Well, the main class is for the maze itself. Looks like the main class runs the test. So let me go here. Runtime exceeded. Pathfinder test failed. And then the other test that failed is not implemented, which is okay. The shortest path, again, is also not implemented. Okay. Those two things that don't fail. All right, back to Claude. Looks like Claude is done. So I'll read this and ask any questions I have. So a small Java maze game, clearly set up as a technical interview exercise, compiles in plain Java and all that stuff. 4 source classes: position, immutable row of calling, row, has move, the row and D calling, returning a new position, plus equals hash code. So it works with a map check. It's simple, but well, being immutable with value equality is what makes the rest of the code safe. Okay. So position the Java, maze the Java, static grid, constructor parses a string of row chars and calling. Validating that one. The grid is rectangular, and 2, exactly S and exactly one S and one E exist. Captures the position during parsing. Poses inbounds, get cells is wall, get start, and it exists. Pure data. Doesn't know about the player. Maze game. Stateful game. Stateful game holds the maze, current player position, steps taken, key method move. Translates UDR into delta, checks the bounds. This also has one. Ensure this path to exit, which delegates to Pathfinder. Okay. Bug with flagging. Wall branch. Still outside. Prevent steps taken before returning false. Would you like me to? Is the goal to make sure these tests pass? So the both integration tests should pass.
Yes, all tests should be passing.
Okay. Sounds good. All right. I'll start with the first one, and I'll basically try to understand what's happening, and then also use Claude to understand and or implement. So there. First, I want to understand the test. So, test run of 3. So maze game test. Oh, that's with that one. All right. So I will tell Claude. Um, so it's failing. Help me understand what it's meant to do and why it meant to do. Context game. So explain how the game logic works using stick diagrams. I'm stuck. Oh, stuff. Tram it and what's meant to happen. So suggests fixes. Okay, so I'm telling Claude the test that's failing, but I also want to understand why they're failing in the context of the game. So I've also asked it to explain the game using like stick diagrams and what's meant to happen. That way, I understand it and also suggest potential fixes at the end of the explanation. So that is the next step. It's thinking. Okay, test. The test sets up a tiny one-row maze and tries to walk the player into a wall. The test sets up a tiny one-row maze and tries to walk the player into a wall. In a real maze game, walking into a wall should be a no operation. That makes sense. The player bumps against and stays put. No step is counted because no step happened. The maze test. Amazing test. So player starts at 0, 0. That makes sense. Hashtag is a wall, and then E is exit. Okay, so this is start, this is wall, and this is exit. Step by step, what should happen? The test calls move right. So you're here, you move right. Player. The test calls move right. So you're here, you should move right. Player position is 0, 0, steps taken is 0. The game computes the target cell 1. Adding 1 to the column, that makes sense, 0, 1, that's a wall. Because the target is a wall, the move is rejected. Steps taken is 0, move R unchanged, still here, that makes sense. The test then asserts 3 things. Move R returns false. The move was refused. Player position is the same as move before, and steps taken is step by step what should actually happen. The bug. Look at service maze. Okay. Service. I'm trying to find the file. Yeah, maze 49. All right. If position is inbounds, maze game, not maze 49 to 53. If maze small. Oh, so the maze is wall. Bug. So the next position is wall. Bug moves wall. So when the next X runs before PE at mode R with the bug code. Before position 0, 0, step 0. After move R. Oh, okay. So the player's position is next. and then the steps taken it increases. Moving to the wall. The method returns false, so the test sees that the move failed, but it also mutated the states to the two exceptions. Player position change after hitting our wall. Yes, it did. It's now on top of this. And then steps to hitting the wall. Yes, steps taken right from 0 to 1. Why this matters? If your wall don't block you, then they aren't walls. Pathfinder, once implemented, has 1. Then 2. Okay. Remove the bug line. Go ahead, print out 2. All right. So the first bug seems to be that even if the maze, the next position is a wall, it does return false, but we still move the player position to the next position and also increase the steps that's taken. So technically, this shouldn't be here, and taking it out should fix the bug.
Okay.
I'll try it and then run the test again to see. Compiles. Okay, the first one passed. Next is the not implemented one. So both fixes rejected valid most. Okay. That one passed. I will now work on the next bug, which is the not implemented method, which is showed as path length. All right, I will tell Claude I'm not implemented. Okay. What is, so I want to understand what the shortest path length is supposed to do in the context of the code. So I'll ask it that first.
All right.
Yeah. And speed contracts the code. Right in the game. Must be intermediates. Red stick goals. Then what's given? All right, shortest path. Given a starting cell, return the minimum number of moves needed to walk from that cell to the maze's exit key. Moving one step at a time. Up, down, left, right, passing only through open cells. Not E, never through walls. If the exit can't be reached at all, return -1. And the rule of a game is the shortest path to exit calls it with the player's current position. So the game can answer from where I'm standing right now. What the US mode I need to win. So it's a hint. Okay. Alcohol feature separate from the player and so on. Test to confirm. To contract. Method vehicle made. Made. Return 5. Okay. So start here. Okay. So from my understanding on the shortest path is, well, with Claude obviously, it's a graph search problem. We can go one of two ways. We can go depth first, or we can go breadth first.
What are the pros and cons of each? Why would you choose one or the other?
So we go depth. Well, let's start with breadth. If we want to find the shortest, we want to do breadth because we are going in levels. So we basically start here and then we go one level, then we go to the next level and go to the next level until we find what we're looking for. As opposed to depth, where if we went depth, we go all the way down, right? We explore one path through all its possible ways. And even after we come back, we just go the next way on that path, right? Then before coming back and then going all the way down. And in that case, it wouldn't be as fast as going breadth since we're trying to find the shortest path there. And so the way to do this would be implementing it via probably you would use a stack for depth first search and you would use a queue for breadth first search. So each position that you haven't explored, right, you just simply add it to the back of the queue. That way you explore it next in the context of other positions as opposed to going all the way down. Yeah.
That's correct.
Okay.
All right.
Okay. I will ask Claude to implement that. So implement the shortest path length using depth breadth first search. Using breadth first search. Breadth first search based on the context of the problem. When you are done, annotate. Explain the algorithm. You implemented. Okay. Actually, before that, sorry. What I had done was ask it to implement it, but I want to see what it implements before it implements it first. So I'm going to ask it to come up with a plan. Come up with a plan to implement the shortest path length method. Explain the steps in your algorithm as it relates to the context for game. I think he had already did that, but let's see what it comes up with. Let's take a look. He answers the question. From the player's current square, what is the fewest moves to reach the exit? All the contracts is defined by this. Algorithm breadth first search, framed for the game perfectly because one step uniform edge weight. So you start here, and then we want to go here. In game terms, each wave represents a square, and moves make sense. Steps, so short circuit is equals to that return 0. Player E. So that's exit, initial queue from the position. We add everything that they visited. Level breadth first search is each level, increment distance, then for each and for every cell currently in the queue, examine its 4 neighbors. So you go up, you go down, you go left, you go right using position.move. If the positions are off the grid, you skip them. If the positions are in the wall, you skip them. If they've already been visited, which is the positions you're storing, you skip them. So a classic breadth first search. Level by queue, snapshot and queue outside of the edge level and looping. And the new helper methods, the implementation composes of this. So position. So this is the position that we're trying to get to, and then if we're there already, return 0. Otherwise, the position you start to create a queue, set visited at the queue for each of the directions. So this is going -1 on the roll is going up. This is going +1 on the row is going down. -1 on the column is going left, and then this is going right. Distance is 0. Okay. Curious on what we're actually returning. return 0, return -1. Okay, so the moment we find it, we return the distance in our search. Okay. Verification safe. Okay. I will tell it to go ahead and proceed. I think it has compiled it, but it's still going. So let me try running the test here. Okay. All of them passed. I want to see what Claude is still doing here. Okay. Yeah, now it's giving me a summary of what it's done. So yeah, looks like all the tests are passing.
Very nice. All right, so I've got some follow-up for you. So this first one, so this shortest path algorithm we just implemented is now just telling us the length of that path. Can you modify this so that we are actually returning the actual path from the start to the exit?
Yes. So in the context of in the context of a searching, so right now what we're doing is we are only storing what we did to get there, but in the context of how we got there, we want to store the positions too, in addition to the places that we visited. One way I can think about doing that is using a map. So as we visit a place, we store it in we use a hash map, right? Location, or no, we're already storing the position itself. So we just need to store the position somewhere along with something. I got to figure out what that something is. Position along with. Position. Each time. Let me ask Claude. I'll brainstorm some ideas with Claude real quick. So, to storing in addition to returning the shortest path, how would we modify what would we need to do to return the path to the shortest path as well? I would need to store the positions we use to get there. So would you want this method to return a different type then?
Yeah, what kind of type do you think would be helpful here? Thinking from like the UI, like what kind of output would the UI use to show this path as a hint?
So we want the position we want the position itself, but we don't want to give the whole thing, right? We don't want to give the user the whole thing. So
Let's say what we want to show is the user in a maze, and maybe they have like a hint button, click hint, that'll like make the whole path show like for a split second or something like that. So
for a second, okay.
yeah, so what output if the UI was calling this method, what output would it need to have in order to do that?
It would need a list of all the positions to get there in the right order.
All right.
Okay.
Sounds good to me.
Okay. We would need to start the positions there in the proper order. Woord net bereik. I'll put this in plan mode as well. The return type should be a list of positions in order to get to the shortest path we have computed. We have found. And think about it. So the set has the places we visited. So each time we visit, well, pretty sure Claude is going to return something, but I was trying to think about it first. So each time we visit somewhere, we add it. But then when we go back, we need to remove it. That would be easier done with a stack, but let's see. Okay. To recover the path, breadth first search needs to remember how it got to each cell. Yeah. So the standard trick is the map that I was talking about, parent position, with parent. Oh yeah, parent next goes to next the moment we discover next. Okay. So this is the previous position and this would be the next position. So that next equals to next the moment we discover next. Once we reach each exit, we walk the chain backwards from exit to finding the river end. Stick diagram. So we start here. Ooh. From here we can then go here. From here we can go here, and then here we can go here. So on and so forth. Reverse it. So from here, boom, boom, from here, this too. Each arrow says parent in that direction. When the wave E, which is E, we stop and walk the arrows backwards. So E, 2, 3, 2, 2, 2, 1. Reverse it. Okay. So we can't modify our shortest path because there's still methods that rely on it. Or rather, the test relies on it. But would you want that to change? Or
This is maybe a good use case for Claude, actually. Perhaps Claude can update the code to accept this new input.
okay, sounds good. Okay. What would the shortest path return when it's unreachable? The empty. Shortest path length should be refactored to like its shortest path. Keeping the existing test area untouched, add the shortest path as dependent method to risk passing pathfinder test. Make shortest path, compute shortest path, and return. Test application would allocate the full path list. So we want to modify the existing shortest path to now return the list of steps or positions to get there, and also modify steps to get there. If the list is empty, then we would return this is empty. Return -1, which is what we're currently already doing. Done -1 if we are at the position itself. So I'm telling you some edge cases here where since we're now returning the list of the positions to get to the shortest path in order, if we're already if we can't find the shortest path, then we return -1. If we're the position itself, then we return an empty list, which is 0. And then otherwise we just return all the positions to get there.
Before you commit that, I'm curious, what are the trade-offs of modifying in place versus just making a new method? Just thinking like if this is a real code base, like what is the impact of doing that versus the latter?
Yeah, so modifying in place, where when you say modifying in place, do you mean changing the existing method to nmap? So if we change the existing method, cons is we now have to go to all the other places to make the changes, which is a con, but we do have Claude that kind of understands the context and can go do that. Let me see. Let me think. If we created a new method to do this, then the existing code stays the same, but we may be duplicating responsibility, if that makes sense. So in this case, what we're doing is we're finding the shortest path, but also wanting to return that length, right? So there's two things that is happening there. So, or we could potentially merge them into one, which is what I'm trying to do here, where we call it once and we get that shortest path, and the length, or in that case, the cons there is, like I said, we're now doing two things at once instead of just doing one thing. But that could be a pro or con depending on how you look at it. So, yeah. So I'm also thinking, so merging it at once will make it harder to test as well, because now there's two things that's happening in the code base and in that specific method as opposed to one. So it might actually make sense to make them split, so that way the test can test. So that way they're easier to test.
Okay. Sounds good.
Okay. I will keep it as is and then just go back to one and then have it do it as recommended after our conversation. Okay. So I made answers and plan. So it'll do the plan. So do we want to? Yeah. So we want to add a second. Do this pathfinder. Keep this pathfinder. So that's this one. So this gets second method returning list of positions. The existing int returns shortest path stays untouched, and the pathfinder keeps as is. Makes the shortest path to exit. Change. Replace. Change pathfinder list. Both method. And kick it the same and add a new method. Okay, so added new methods, that one that just returns the shortest path, and then another one that then does that, but with the length as well. So there are two separate methods that can be tested separately.
How do we test the new method?
That is a great question. To test the new method, we can use our existing test actually. So off the top of my head, do we want to test the actual visual part of it or the logic behind it?
I imagine just the logic.
Okay. All right. Let's test the new method that returns. Let's get the test and return the test. I test the new. Yeah. Yeah. So we create some boards. How we do in manual is create some boards with different positions, like the 1x1 row, and then test different configurations of the board, right? Where we know this is the shortest length and this is also the shortest path. So the shortest path in this case should be blocked. Shortest path in this case should be 1. Yeah, path size 1 here. The shortest path in this case should be 6. Okay.
Is that test doing what we want it to do? Is it testing the actual path output, or is it just testing the path length again?
That is a good question. is empty. All this runs. Let me inspect what it's doing. The size is there. Yeah, it is not testing. Well, for it to test the outputs, it'll need to create them first, but then there could be multiple. So, give me one sec. So, add test, control. Well, here it's testing the first position and it's testing the last position, but then it's testing that all the positions in the shortest path are not walls and are inbound. And finally, it is testing that the previous position. Yeah, it's testing that all the positions to get to the final position are adjacent. They're either up, down, left, or right. So it is testing. It's testing that it's valid, but what I would probably suggest for how I would probably test it would be to actually have the inputs and the outputs. And rather, an additional test I would add is to have like a grid, known positions that are 100% sure that this is the shortest path, along with the positions to then put that grid through and then make sure it actually returns what I expect as well.
Absolutely. I agree.
A test. Add a test. Turn. That relies on information from an actual grid, along with outputs, which list of Gapali strip non-shortest paths to get there and test the return is the same as the non-shortest paths. Okay. So open corridor, so you go here, then you go down. So it's 0, 0, 0, 1, 0, 2, 1, 2, and then every other direction it's a wall. Yep. And then, yeah, go for it. That's that method. Yep. From run, compile and run. All right, all test fast.
Sounds good. Alrighty. So I got one last ask for you. So assume that we want to call shortest path after every single move. How can we optimize this so it's not taking that full kind of repeating this whole calculation over and over and over again?
We want to store shortest path after every move. How
We're gonna call, at least we want to call shortest path after.
want to call shortest path after every move? The map does not change, right? So we can keep a log of the shortest path after. So I'm trying to visualize this. So we have our map. We're here. we call shortest path here, and it calculates. But as part of the calculation, we basically calculate from where we are to the shortest path. When we then move to the next path, it'll be one less, technically, from where we are to that shortest path, since the map stays intact. That's my assumption.
What if the user doesn't go that way? What if they clicked shortest path, saw it, but they went a different way?
Then we would technically, so shortest path this way, and then they went this way, then we'll have to calculate shortest path this way, right? Going a different way. So it's almost like a dynamic programming problem. That's how I'm thinking about it. So we could start from the end and figure out the shortest path from the end all the way back, right? That way, whenever the user is at a certain cell, we know what the shortest path is from where they are. So we could do this calculation once for every spot on the cell on the map. That way we just call, and then we store it on a 2x2 grid, for example. And then that way we know what it is. So we pre-compute it. That way we don't always have to call it every time.
I like it. You want to give it a try to implement that?
Yeah. Okay. Let's do this. Okay. All right. First, let me think about where I would put it. Yeah, it'll still be in the same place in the Pathfinder. So, in the Pathfinder, let's create, in the Pathfinder class. All right. Thinking it may need some context here. All right. In the Pathfinder class, we have a maze that will not change. Instead of calculating, I'm thinking, will we still have, is this specific to only the length of the shortest path or the direction as well?
The actual shortest path, right. So we want to basically make it so every time we call shortest path, it's effectively just constant time. We can do some pre-calculation, pre-processing data, since you make the correct assumption that the maze will not change for the game. So
in this we shortest path every time we want to compute the shortest path from the end to every possible. So we want to pre-calculate for that path from the end to every possible valid position and store the length or path along the direction in data structure. So every time we get that call, we don't have to do the search. Search in just buttons. It's the path and the first. Okay, so I've asked it to come up with a plan to pre-compute from the end to every valid position and store it in a data structure. That way we only call it once. So based on what it comes up with. And
while Claude is thinking, maybe we can think of a way to test this.
Similar to the test that we had here, we can pre-compute all the before we do that. Similar to what we have in our test, Pathfinder test, pre-compute this and then store it, but we wouldn't know. Well, if we test our function, we can then test that the output of our pre-computed one for the map is similar to what our Pathfinder class pre-computes. That's one way we can test it. Another way we can test it is going to test the implementation in constant time. But if we're calling a function that we know is running in constant time, then because it's returning a specific point and not doing any calculations, then there may be no need to test that. Does that make sense?
That does make sense. Another option, we could just use like timestamps. We can like calculate like the latency. Maybe we like test. how long- Yes.
Yeah.
Yeah. But that's a
Yeah.
good. No, this is great. We're actually out of time here. But you did an excellent job. Thank you so much for your time. Yeah, your recruiter will be in touch. And yeah.
Thank you.